In this video, let us solve a couple of more trigonometric identity problems. So let's get started. Please pause the video and try it yourself. If you have any questions on how to approach few problems, please refer to the other videos in this playlist. Also, if you like this channel, please share it and subscribe. Thank you. Let's try to solve the first problem. I hope you have paused the video and given it a try yourself. So here we have to prove that sine cube x plus cos cube x divided by sine x plus cos x plus sine cube x minus cos cube x divided by sine x minus cos x, this is equal to 2. Now the numerator is sine cube x plus cos cube x, which is nothing but of the format a cube plus b cube, which is a plus b times a square minus b ab plus b square. And the other part of the question is a cube minus b cube, which is sine cube x minus cos cube x. So this will be a minus b times a square plus ab plus b square. So let's apply this to the problem now. So sine cube x plus cos cube x can be replaced with sine x plus cos x times sine square x minus sine x cos x plus cos square x, and the denominator would be the same, sine x plus cos x, no changes there, plus the second part would be a cube minus b cube. So this will be sine x minus cos x, which is a minus b, and the second part would be sine square x plus sine x cos x plus cos square x divided by, there is no change in the denominator, so it will be sine x minus cos x. Now we can cancel sine x plus cos x in the first part and sine x minus cos x in the second part. Now let's compare and see what else can be cancelled out. So minus sine x cos x and the positive value of sine x cos x gets cancelled. So we will have 2 sine square x plus 2 cos square x, which is nothing but 2 times sine square x plus cos square x. This will be 1 because that's the trigonometric identity, so we'll have the value 2. So this is how you can prove the first trigonometric question, identity question. Now let's solve the second problem. Here we have to prove that tan cube x by 1 plus tan square x plus cot cube x plus 1 plus cot square x is equal to 1 minus 2 sine square x cos square x divided by sine x cos x. So we see that the left hand side has tan and cot values, but in the proof that we want to achieve, it is sine and cos. So let us define tan and cot in terms of sine and cos. So what we can write this as, tan cube x will be sine cube x by cos cube x divided by 1 plus tan square x is secant square x. Then the second part is cos cube x by sine cube x divided by 1 plus cot square x is cosecant square x. So let's further change this. So secant square x can be written as 1 by cos square x. So this will be sine cube x by cos cube x divided by 1 by cos square x plus cos cube x by sine cube x divided by 1 divided by sine square x. So the square and the cube gets cancelled, not completely, we retain one of the cos values, and here it's the same way. So this will be, denominator will be sine. So Now the equation has changed to sine cube x by cos x plus cos cube x by sin x. Now let's find the common denominator between these two parts of the equation. So we would have sine to the power of 4x plus cos to the power of 4x divided by sin x cos x. Now whenever we have such a situation where we cannot solve further, we have to see if in some way we can change the equation to a plus b the whole square, or a minus b the whole square, or a square minus b square. So any of these algebraic expressions. So now if we see the required term here, we have 1 minus 2 sine square x cos square x. So let's try to change it to a plus b the whole square. So let's add and subtract 2 times sine square x cos square x to the numerator. So we will have sine to the power of 4x plus cos to the power of 4x minus 2 sine square x cos square x plus 2 sine square x cos square x divided by sin x cos x. Correct? So if we combine this part, sine to the power of 4x plus cos to the power of 4x and 2 sine square x cos square x, we would get sine square x plus cos square x the whole square minus 2 sine square x cos square x divided by sin x times cos x. Now this will result to the value of 1. So basically we have achieved the right hand side we wanted. So this will be 1 minus 2 sine square x cos square x divided by sin x cos x. So this is how we can apply the algebraic equations to find the right hand side of the proof. So please keep these tricks in mind. If you like the video, please share it with your friends and also subscribe to the channel. I'll see you in the next video. Thank you.